So we're going to start this module with an example from an introductory astronomy course taught at Vanderbilt. In this course, the students are mostly non-majors and meet once a week for 3 hours for the lab. They do projects that are short and can be completed by individuals or by pairs of students in a single 3-hour block. You'll hear from the instructor and a couple of students in the lab, and I encourage you to pay attention to what they have to say about student motivation and responsibility in this lab.
So today I'm trying to figure out what spectral type star is most common in our universe. And I'm going about that using this program here, actually, SCOPE, which you look at the spectral lines of various star clusters, and then you try to match it up with different spectral type, known spectral type stars. And then, so you can classify the stars and figure out kind of number-based what's the most common in the universe. I think the main thing for me was that, you know, whenever you look up at the stars, they all look very similar. And up until I took astronomy this year and I got into this lab, I didn't realize that every star has its own kind of personality, its own characteristics. And so I got interested in this to see, you know, when I look up how many of these stars are like one type versus the other, and then how, like now I can look up and kind of see based on color, like, oh, this is an O, or oh, that's an M. So that's kind of been a cool transition for me, and so that's why I picked this question.
This is kind of a style that people have called backward faded scaffolding. So you provide a lot of support right away, and then you kind of gradually take away the supports over the course of one lab. So during 1 2 to 3 hour lab period, they first will look at like the website that we're going to have them gather data from or harvest data from, and then they get to know it. And then they look at an evidence-based conclusion that we have given to them. And then they say, yes, this is true, or no, this is not true, and why. Then after that, then they start looking at just a data table that's already given to them, and then they make an evidence-based conclusion from that. Then they have to design a procedure in order to get evidence-based conclusions. And then they actually make their own question, a procedure, gather the evidence, and then make the evidence-based conclusion. In this particular lab, there are 12 labs, and 6 of them are this inquiry-based style, where it's the backward faded scaffolding style. After having been trained on how to actually make evidence-based conclusions and create answerable research questions in general, they are creating a poster. And it is really just 9 PowerPoint slides, but it's a poster, and you can see some behind me. And they are going to present it to each other, and they're going to evaluate each other. And so they've just been trained, and over the course of 3 hours, they design a question, gather the evidence, and make their poster. We give them an entire lab period to actually do that. And then they present for about 5 minutes or 10 minutes, and they really start to own it. They really are excited. They're very passionate about what they find. And a lot of times they're like, yeah, I didn't really know that when I first started this. I didn't know anything about galaxies. I didn't know anything about how galaxies might interact. And they start taking that and making it part of what they now understand. So it's really exciting.
Once a week you come in the lab, you're kind of given a topic, and then you decide the question you're trying to figure out. Earlier in the lab, it was assigned you the question and then the procedure, and you just followed it. Then as the lab went on, you were given more and more personal freedom and personal control over the process. And so the lab last week, you were actually designing your own question, designing your own procedure, going through with the procedure, and then coming up with a conclusion based on the results. So some of the labs earlier had, where you kind of knew what the end result was supposed to be from lecture or from personal experience. And so when you followed the procedure, you knew if you were on the right track. And now as it's gone on, now we kind of design our own experiments and design our own procedures. and we come to our own conclusions, which is personally very cool for me. Say at the beginning, when we were still learning the process and the procedure and how to do everything, and then gradually as the semester moved on, she backed away a little bit to give us kind of that personal freedom to do with it what we wanted. That being said, she's always here for help, guidance. She obviously knows a lot more than I do, so she can help kind of direct you in the right direction.
So I think presenting is super important because it is something that students will have to do no matter what field they're in. You always have to present something. And then in order to communicate something, you do have to understand it. So having them be kind of responsible for a presentation, I feel really helps them really get to know what they want or what they've been learning, and really kind of make them accountable for it.
I took a special interest in the spiral galaxies when we started learning the different types of those. So I thought there might be some sort of correlation between clusters. Again, we tend to study clusters in order to see similarities in different parts of the universe. So I wanted to kind of develop a spatial map of where these different spiral galaxies are.
The skills that this lab gives you is the skills, to look at something and figure out how you're going to approach it and what you want to get from it. Or not what you want to get from it, but how you want to proceed figuring out what it is that's being offered. This helps you kind of gain the confidence to ask a question and then go through with it, and then be okay if the answer's not what you expected, which is actually happening with the lab I'm doing right now. And so it definitely gives you that extra confidence and that extra experience, kind of leading your own self, your own discovery and your own process.
This is really fun to actually see the students really come alive when they're doing this. And I think that everybody should have this, every teacher should have this opportunity to see the passion that their students can have about something that's totally not their field. So I really love that. It does take some time to figure out how to make this happen, but other people are already doing this. You don't have to reinvent the wheel. And you can take what other people have done and you can use it. People are putting it out there. And so you can get together with different education research groups in your field, and they probably already have something that can be used. So the inquiry-based approach, there's also the lecture tutorials. Those are really good things to use. And it's just one of those things where I just have so much fun doing this. And I think that it is way more useful than discovering something that people have already done.
So here we saw an example of inquiry-based lab pedagogy in an introductory lab that largely targets non-majors. In what ways does this approach differ from a traditional lab? In what ways is it similar? And in what ways does this approach mimic what we think of as real science?